Hi everyone. Today I'm going to just do a little bit of a run through of the Unit 1 Things to Know Part 1. This might seem like a big document, but it's really just a lot of graphs which take up a lot of space. And essentially because we're down to two FRQ problems on the AP test, you will probably have to analyze some type of visual display of data. There will probably be a lot of things tied into it. So it'll be a kind of a connection of multiple chapters. What you're seeing here is just strictly Unit 1 without too much connection to future chapters. And I just want to get your brain remembering how to, analyze and interpret these various visual displays. So a lot of this will be review. A lot of it might seem like I'm teaching, you know, like if you I'm just scrolling through here, a lot of these displays you might not see on the AP test, and that's okay. It's all about getting your brain to think about interpreting a graph of some kind and knowing what you're looking for. That's a good thinking skill that'll help you guys out. So, things to know, part one. What we started off the entire year with was the difference between categorical and quantitative variables. So, categorical, remember, we tend to say words. You've seen this more in recent chapters when you did hypothesis test for proportions. Proportion, like, it has to do with answering yes or no to a question, and yes or no to a question kind of falls into the category of categorical. And so that's sort of where you see displays of that talked about and used, not so much with the hypothesis test, but if you were asked a hypothesis testing question, you may be given one of these types of visual displays to analyze. And they include frequency tables or relative frequency tables, bar graph, segmented bar graph, dot plot, pie chart. I highly doubt you'd have to draw one of those. The things that they might ask you to draw would be more quantitative in nature. Those are variables with numbers and units, and those include our box plot, stem plot, or stem leaf plot, and histograms. That's what you've primarily learned to graph, and that's probably what you'd be asked to produce if you had to produce a graph of any kind. So, that said, let's talk about a few things here, starting with categorical displays. And again, I wrote here, these don't show up that often, but you never know. And just again, to get your brain thinking. So, a key thing I'm going to talk about with you is the difference between a regular picture and what's called a relative frequency picture. And this little caption here helps explain that in a relative frequency, anything, you're basically looking at percent. So you notice the graphs are the same. But instead of telling me the count of people that were first class passengers on the Titanic, that's where this data came from, this tells you the percent of all passengers that were first class. Again, they look the same, but you want to make sure you're checking your title and your axis labels to know exactly what you're looking at. Now, relative frequency usually isn't done as a bar graph, it would be done as a pie chart. And again, same idea. These could have been counts, like you see right here, I'm comparing those two. They could have easily put percents on this picture too. So again, just know what you're looking at, understand what the relationship is between what you're being presented and the data that you are kind of analyzing. Now, this isn't really a visual display, this is just a way to organize data. If you remember frequency table or a contingency table, that's just when you have multiple rows and columns of data. Again, these are counts. You can see right here that they even give you a total. Sometimes that won't be provided. You'd have to find it. We briefly talked about this in Unit 1, the idea of a marginal distribution. That's just kind of telling me the totals for a particular variable. So it's kind of like the numbers in the margins. And again, you can see right here, these are two pie charts that same data, same stuff here, but separated into alive and dead, like who survived, who didn't. And that would be a way of kind of like breaking down the data, getting a little bit more refined, and that's what's called a conditional distribution. It's conditional on one of your survival or your lack of survival. And again, you would not have to create a pie chart. There's no way that's going to be a question on your test, but you want to be able to read one and understand what's going on if they had given you labels here. And lastly, just to tie these all together one more time, a segmented bar graph, if you ever see this, I think I have seen this on an AP test before. It's basically a pie chart, but in rectangular form. And it is relative frequency because you can see here your y-axis goes to 100%, and you can sort of estimate the percent of the crew that survived, the percent of crew that perished in the Titanic. So it gives you a visual understanding. It kind of gives you an understanding of approximately the percent of data that falls there. And you can maybe compare this a little more easily than you could a pie chart, because here you can see numbers, whereas here they didn't give you any. So again, that was all categorical. Again, just really wanted to stress the idea of relative frequency, meaning percentage of the whole. That'll come up later in this video. Now, quantitative displays. This is what you see much more often. This is where a lot of our Unit 1 material came from. So again, I'm going to talk about these as if you don't remember what a histogram is or a box plot is and so on. Remind you of a few things that you could read on your own, but just kind of point them out to you. And then we'll get into a little bit more unusual displays. So up here with histograms. Remember with a histogram, it's sort of like a grouped bar graph. Each group, they call them bins. So like you could say there's a bin from here to here, or like 5 to 5.2 and 5.2 to 5.4, or whatever the x-axis labels are. And again, the y-axis usually is a frequency. It's the number of pieces of data that are between two values, your bin values. Now, it could be relative frequency. And again, this would be percent of earthquakes that had a 7 point whatever magnitude, percent of earthquakes that had a 5.5. But we tend to see regular tallies on the left, or on the y-axis rather, but you could see relative frequency. And again, just understand that it doesn't mean there were 16 earthquakes. In this case, it would mean 16%. So you got to read your margins and read your axes carefully. Note if you are making a histogram by hand, if your data falls on the tick mark, it always moves to the bin to the right. If you do this on your calculator, it will automatically do that. You don't have to worry about that. And here is a calculator note on how to make a histogram if you forgot. If you want to do a frequency one, because maybe you have multiple like of the same data, this guides you through that. That is not required. But if you forgot how to enter data and make a histogram, it is all explained right here, as well as the relative frequency one. But again, that is not as common. Stem leaf plot. Again, main thing to understand here, the stem could be the tens digits or the hundreds digits. It depends how they are describing it. So check your legend. And in this case, it says here, line 8 means 88. So we know the left is tens and the right is ones. You can see here that you basically count out, keep your numbers lined up. Again, I highly doubt you'd have to create one. You might have to interpret one. Sometimes these are back to back, where the tens digit is along the center column, and then you have one group to the right and another group to the left. So be careful in reading those if it is a back-to-back one. This goes on to say, if this was too much data, you might, like if here, you can see 432, 540. This is rounding down or truncating, they call it. That might be a quicker way to write out what these values are, because 432, the idea is that would you write 4 and then 3 and then a 2 on the right? Would you write 4 and then a 3 and a 2? This kind of prevents you from having that confusion over what do you do if you're dealing with hundreds places. You may just round them all down. So again, you have to read what I call it the legend or the description of the graph or the key, whatever you want to call it, is telling you. But again, I doubt you'd have to make one of these. You might have to interpret one. It helps to have these in order from least to greatest. So I would maybe flip this around, because if you were to turn this on its side, like physically rotate it, it sort of looks like a histogram. Okay, so moving on from there, we're going to look at a dot plot. Remember, dot plots are basically kind of like a bar graph, to be honest with you. But instead of just drawing a bar up to a certain height, you draw a number of dots to represent the frequency. So these are winning times in the Kentucky Derby. And if there were two horses that won with a time of 133 seconds, that's why you see two dots. Notice in all these cases, even histograms, they could be drawn horizontally or vertically. And this will kind of talk about bimodal. We'll get to that later on. If there's a huge gap in your data, there's usually something up, and we'll kind of talk about that again when we get to bimodal. Okay, box plot, very common. Guarantee you'll have to do something with one or have to maybe draw one. Remember, this is a visual display of essentially your 5-number summary. the 5-number summary meaning the min, the max, those are the smallest and largest data points, as well as the first quartile, the median, and the third quartile. Now, I wrote right here, remember 25% of the data is between each aspect of the 5-number summary. Even if you have outliers, they're still part of that 25% grouping. And quartiles are specific numbers that act like percentiles. So a percentile in general, if you're in the 8th percentile, that means 8% of the data is less than or equal to that amount. So if you scored in the 90th percentile, that means you did better than, or 90% of the scores are less than or equal to yours. So quartile is just because they're all 25% increments. First quartile is like the 25th percentile. The median is the 50th percentile. Q3, the third quartile, is the 75th percentile. Remember that outliers are extreme values. You can't just assume something's an outlier. You have to prove it given data by using these formulas for lower fence and upper fence. If you are lower than the lower fence or greater than the upper fence, you're an outlier. So I made a note here. Sometimes people found lower fence and called it an outlier. That is a cutoff for the outlier. So here you can see a little visual of how to do that. Remember, it's sometimes called a box and whisker plot because the box is always Q1, median, Q3. It could be drawn vertically or horizontally. You can see here that they put in the fences, the lower fence and upper fence, using this formula. Then they drew their whiskers out to their min and max. If you have outliers, remember, they would be outside. They'd be either like asterisks or dots, something outside your fences. And then you would draw to whatever was the data point just before the fence, and then make sure you highlight those outliers with markings like that. Calculator can do that as well. Here are the steps for that. Again, I would pick this option right here when you do a box plot. That one includes outliers. The one to the right does not. Now, what's cool, if you forgot how to find a 5-number summary, you could literally just do this box plot trick here, and it gives it to you. You can trace along the box plot, and it will tell you the 5-number summary. If you don't have to actually create a box plot, right here describes to you how to enter the data and find that. All right, now, taking a quick break from that. CUS, I guarantee you will have to do something with this. Anytime you're asked to describe a distribution, you want to remember these 4 things. C stands for center. You'll want to be able to tell me something about the mean and the median. This gives you a really nice summary right here. But again, you won't be able to find the mean. You will tell me how it relates to the median. The median you will be able to find in a histogram, and that gets talked about a little bit down here, where if I could see, for instance, this histogram, I would count or estimate the height of each of these bars, and then I would find the middle value of them. So if there's 100 data points, I would look for where is the 50th one, and you'd give an estimate. You'd say it's in this bar or it's in this bin. The mean, as you remember, if there's skew involved, directs the mean and the mean follows the skew. We'll talk about that in just a second. Here gives you another description of how you could find the median on a histogram. Unusual, that's the U of CUS. Don't just say there is an outlier. Unusual can mean you have a large gap in your data. It can mean you have a potential outlier. Again, use words like that. Don't say it's guaranteed unless you can prove it. The shape has 2 aspects to it. You have to tell me about the number of modes, or like the form of the distribution, and then if it's symmetric or skewed. We will talk about that on the next slide. And lastly, the spread. Now, measures of spread include range, which is max minus min, interquartile range, or IQR, which is the middle 50%, the length of the box in a box plot, or just Q3 minus Q1. Standard deviation is also a measure of spread. Now, you can't necessarily find all of these from just a picture of a histogram. So you could probably guess the range. The IQR, if you have a box plot, you could estimate. But basically what you'd say for this part of CUS is the following. Remember, mean and standard deviation are used when you have more unimodal and symmetric data. Median and IQR are used when the data has a skew. So if there's a skew of some kind, it will influence the mean and standard deviation, but 1 or 2 extreme values won't really affect the middle values, and that's why you'd use these different measures in those different scenarios. So make sure you know which to pair, which measure of center and spread. And again, you could say something like if you had a skewed histogram, my data is less consistent and has more variability. It's generic, but you don't have to go into detail. You could say if it's a little bit more symmetric, hey, I probably have pretty consistent data with less variability, and therefore I would use mean and standard deviation, for instance. Now, you don't have to literally write CUSS, because as you can see, sometimes when you start to mention the center, you inevitably mention the shape. So you kind of say things simultaneously. CUS is just a good way to remember the pieces you need to know when you describe a distribution. Now, a little bit about those specifics. Bimodal. Just because you have two peaks doesn't mean you're bimodal. Like you might have a bar here and a bar here. This has at least three here between it. I would say this is bimodal. That's a decent amount of space between these two peaks. Here, with the data from Kentucky Derby, this is definitely bimodal. You had a chunk here, huge gap, chunk here. Remember, if you are bimodal, there's usually a reason why. In this case, if you remember, this was a different race length than here. They changed it at some point in history. Sometimes you have bimodal data like here for blood pressure because maybe females and males have differing base blood pressures. So anytime you're bimodal, think this might have come from two different groups in my population. That's why blocking is talked about in Unit 3. Uniform is when you're all about the same height. Unimodal is when you have a single peak. Now, not every unimodal thing is normal, so I don't say this is normal, say it is unimodal. To be more normal would be if you're unimodal and symmetric. So here you can see symmetric is when you're basically the same to the left and right of what would be the mean or median, which tend to be the same. And this graphic here shows you when you skew left, it pulls the mean with it. The mean will be less than the median. And mode, I know you learned mode probably back in like third grade. Mode is the peak because it is the amount that occurred the most often with the highest frequency. Hence, it's the peak. Remember, if you skew right, you pull the mean with you. The mean becomes larger than the median. So remembering those relationships should help you, particularly when you have to compare distributions. Now, this would be very common. You may have even seen this in the review I gave you. They'll give you two or more histograms, two or more box plots, and say compare them. So you have to talk about CUS for the most part for each of them, but you also want to say, like, for instance, you might say something like the middle 50% of this box plot is less than 75% of another box plot, or the medians all tend to be the same, but this set of data is more skewed. So when you're comparing them, you're kind of looking for similarities and differences amongst the visual displays. A couple other things just about Unit 1 before we get into unusual distributions. If you're ever asked to add in a missing value, they might say, oh, we recorded another earthquake. It had a magnitude 9. What would that do to our picture? What would that do to our measures of center and spread? So remember, if you have the data, you could just add that into your calculator and calculate a new mean or median. If you add something, people, on the edges, you will influence the mean because you have to add in that new amount, but the median isn't really necessarily affected that much by an extreme number. So if it was added to every piece of data, that's different. So right here, if you add or subtract data to every single piece of data, you will increase or decrease the mean and median by that amount because you added it to every piece, but measures of spread are unaffected. Think of that as like a horizontal shift on a graph. You changed its x locations, its measure of center, let's say, but you haven't changed its range. Now, if you multiply or divide every set of data or every point in your data set, then the mean, median, standard deviation, range, and IQR all just get multiplied or divided by that same amount. So you don't have to literally change 40 data points. If it says you doubled them all, you could just double the mean or median if you knew what it was. Okay, these guys, this may not show up. But again, I just wanted to show you that these are unusual graphs that, again, you might want to be on the lookout for. Time plot is not that bad. Time is your x-axis, and this is basically measuring wind speed in this case at different days throughout the year. So this is through the passage of time, what happened. So that's not too unusual. You've seen those before. These I would be careful of. Cumulative. Again, we're looking at that word cumulative. If you see that word, it almost always means 100% is talked about. Now, this data here is literally from DuPage County, Illinois, because they had some good graphs to work with. This bar graph is just a bar graph saying every day from March 13th through April, I think it was 4th when I took this picture, how many cases had they reported in the county. So it was like one new case, one new case. This day there were 34 new cases. Then it was 9. So you can see that each day, there's some days it dropped considerably, there's some days it jumped considerably. But then here, this is a cumulative line graph of what's going on. So again, notice how this first dot is 1, but the second dot is 2, because now there are 2 total cases by that day. And then when you add in this next group, there are now 4 total. So this is telling you the total number of cases. And what can be misleading, or if you watch the news and they don't tell you, they might not say this is cumulative. And you might think, oh man, there's 458 new cases, 515 new cases. Oh man, what's going on? When really, it's the difference between these that's describing the number of new cases per day. So look for that word cumulative or not to kind of understand what you're looking at. Now, a cumulative frequency graph, and again, since we don't know when this virus will end, this doesn't have like a peak of 100% yet. It has actual counts as its y-axis. If you did have a percent, it's called an ogive. Now, again, what this is saying is that over time, you are going to end at 100%. Ogives always start at 0, end at 100%, and you're watching the increase over time. So you might be asked, what was the increase from 1 to 9 to 10 to 19? And you went from 20 to 40. So you could say there was like a 20% jump. All right, again, it's jumping by percent, not by physical number. And these will always, again, end at 100. We made one of these in class, but if you want to see an example of it, I would click on the link there. Again, not that you'd have to make one of these on the test, guys, but to know how to read one, to understand that this is the cumulative growth over time, okay? So